No,
No,
sir.
sir.
Okay.
Yes, now it's
Yes, sir.
Now is because I am 2 to 5 minutes late due to join this because we are our fifth semester examination examination duty is going on. Okay, for this reason I am little bit late. Yeah, so already I have shared one YouTube link. Have you checked or not?
Yes, sir.
Yes, sir.
yes,
Okay,
sir.
okay. Now please write down. Please write down linear combination. Please write down linear combination is a heading. Linear combination as a heading. Let capital V be a vector space over real number set R, and let alpha 1, alpha 2, alpha 3 dot dot alpha n from V. Then a vector beta in V is said to be a
Is sweet.
linear combination of the vectors alpha 1, alpha 2 dot dot alpha n if beta can be expressed as beta is equals to C1 alpha 1, C2 alpha 2, C3 alpha 3 plus dot dot Cn alpha n. It means any vector can be expressed like this. Then this expression is called linear expression of alpha 1, alpha 2, alpha 3, alpha n. Okay, where you can write where C1, C2, where C1, C2, C3 dot dot Cn are scalar, are a constant. You can see. Okay, clear? Please write down the definition. So that means, so from here it is clear, this alpha 1, alpha 2, alpha 3, alpha n, these are all coming from V set, and beta is also coming from V set. Same, all vectors are coming from beta. There is V and beta, alpha 1, alpha 2, those are all coming from V. If it is possible to express beta in terms of alpha 1, alpha 2, alpha 3, then this relation is called linear combination of alpha 1, alpha 2 dot alpha n. Now, if you have a doubt, then try to rectify your doubts with some numerical example. Numerical example. Okay. Shall I move to the next slide?
No, sir.
R. So C1, C2, C3 dot dot CNR.
Are constant. Are constant. Are constant. Are constant.
Sir, what is alpha 1, alpha 2, alpha 3, and so on?
These are all
Alpha n?
vector. These are all vector. I will give you some numerical example, then you can understand everything. Just wait. Just wait. Just wait. Shall I start?
Yes, sir.
Okay. Now, write down the question. Listen carefully. Very important part. Express alpha is equals to 435 as a linear combination of beta 0, 1, 3 and gamma 2, 1, 1. Listen carefully. We'll try to understand. So you want to express alpha in terms of this. Okay. Okay. Now you write down solution. Here alpha is equals to 435, beta is equals to 0, 1, 3 and gamma is equals to 2, 1, 1. So from the statement it is clear that you want to express alpha in terms of beta and gamma. Okay, then you should write let alpha is equals to C1 beta plus C2 gamma. Is it clear or not?
Yes, sir.
Because you want to express alpha in terms of beta and gamma. So that's why I'm writing let alpha is equals to C1 beta plus C2 gamma. What is C1, C2? C1 and C2 are real constant. That means it is a constant value, but it's a real number. Okay, now you substitute the value of alpha. Now what is our target? Our target to find the value of C1 and C2. So this is our target. Okay, now let's see. If it is possible to find the real value of C1 and C2, then only we can say alpha can be expressed as a linear combination of beta and gamma. Suppose you have a question in your mind, sir, if we are unable to identify the real value of C1 and C2, then so in that case we can say that alpha cannot be expressed as a linear combination of beta and gamma. Is it clear to all of you?
Yes, sir.
Sir, can you please repeat,
Yes,
sir?
sir.
Definitely I can repeat, no problem. After writing this expression as a linear combination, our objective to find the value of C1 and C2 as a real number, real value, not complex, real value. Okay. Now sometime you can see the situation, you can find the value of C1 and C2. Sometime may not be calculate the value of C1, C2. Then if you can calculate the value of C1 and C2, then we can say the alpha is a linear combination beta and gamma. But if it is not possible to find the value of C1 and C2, then we should say alpha cannot be expressed as a linear combination of beta and gamma. So from here it is clear, ultimately our main focus to find the value of C1 and C2. Clear? Is it clear?
Yes, sir.
Okay, okay. Now you
The
write down
number should be real number, na? Not
real number. Now you write down what is alpha 435. What is beta? Beta 013. What is gamma 211? Is it clear? So from here you may write 435. Here you can write 0 C1, C1, 3 C1. Can you write this? Can you write this?
Yes,
yes, sir.
Yes, sir.
435 is equals to, if you add component wise, that is 0 C1 plus 2 C2, C1 plus C2, comma 3 C1 plus C2. Can you write this? Is it possible to write?
Yes, sir.
Okay.
Yes, sir.
So from here you may write 2 C2 is equals to 4, C1 plus C2 is equals to 3, 4, 3 C1 plus C2 is equals to 0. Correct? So
Yes.
you are 3 C1 plus
Yes,
C2 is equals to 5. Now what is our objective? To find the value of C1 and C2. Now simplify and tell me what is the value of C1 and what is the value of C2. Now anyone please tell me.
C2 equals to 2,
C2
sir.
equals to 2.
C2
C1
is
equal
equal to 1. C1 is 1.
Okay, now let's see whether this value satisfies third equation, yes or no.
Yes, sir.
Yes, sir.
Okay, so that from here it is clear we have valid real number, correct? C1 and C2.
Yes, sir.
Okay, okay.
Yes,
Now say, now we can say now we can say now
স্যার লাস্ট পেজটা একবার শো করবেন? ওকে স্যার, থ্যাংক ইউ।
now you write down therefore 435 is equal to what is your C1? What is C1 value?
1, sir.
C1 equal to 1.
Now we can check. Is it clear?
Yes, sir.
So you can write down alpha is equals to 1 beta plus 2 gamma. So therefore you can write hence alpha is the linear combination of beta and gamma. Clear?
yes, sir.
So this is the process.
Yes, sir.
Suppose you have a question in your mind, what does it mean, sir? What does it mean? Linear combination means what? Basically what? Now listen carefully. Listen carefully. Try to understand this. This is your university. This is your another university, Jadavpur University. Listen carefully. One coding competition will be held. For example, listen carefully, very interesting point. Then you can understand the logic of linear combination. Suppose one coding competition will be held in next month. Okay, and they have communicated our university so that we can convey the message to our students. Suppose we have lots of students. Now one group of member wants to join this course or wants to participate this course. Okay, wants to participate this course. They can apply and fix date. They can participate. Okay. Now listen carefully. Suppose you are performing well. Suppose you are performing well. It means what? So Jadavpur University organizer, that means those who are organized this program or coding competition, they can feel good about your performance and they can feel good about our university also. They can understand, okay, Jishu providing the good quality of education to their student. Am I correct?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So it means what? You are the representative. You are the representative of Jishu, or you are the brand ambassador of Jishu. But suppose in art, okay, but just reverse it. Suppose your behavior towards the organizer is not good. Suppose you have misbehaved with organizer, that they are thinking that you are most third class and your university also most third class. Am I correct?
Yes, sir.
Yes, sir.
Okay. So from here it is clear, if you perform well or if you do good or you behave good, then anyone can understand you are a very good student. As a person, you are very good, as well as your university also good. But if it is reverse, it is automatically their perception about you as well as your perception about your university become different. Now try to understand how many students you have. We have near about 3,000 students. Throughout the university, we have near about 3,000 students. Listen carefully. But how many students participated in this course or workshop? Maximum 20. Okay, so from here it is clear that by operating 20 students, they can understand, they are not, it is not possible to understand everything about university, but they can predict, they can feel that yes, their students are good and university also providing the good quality of student to their student. Okay. So same thing is here. Suppose anyone due to some problem, one student don't want to join the course. Suppose due to some problem, anyone of our student wants to withdraw his or her name. Okay. They want to withdraw. Oh. They wants to withdraw their name or his or her name. Now you tell me if then automatically from other students should enter this place. Okay. Now this here alpha is a new student. Okay. If alpha can satisfy some condition, then only this alpha can enter this position. Is it clear or not? Is it clear or not?
Sir, repeat.
Suppose anyone of our student wants to withdraw his or her name, then we should add another student like alpha. Okay, if alpha can satisfy some norms or condition, then only alpha can enter to this position.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Same way. So here you are representing alpha with the help of others. Okay. Are you getting my point?
Yes,
Is
sir.
it? Okay. Now you try to understand with some another example. Now, another example, try to understand. Express -1 to 4 as a linear combination of -1 to 0, 0 -1 1 and 3 -4 2. Listen carefully. Now anyone can tell me what is the difference between the last question and this question? What is the difference? Anyone?
স্যার মানে যেটা স্যার কম্বিনেশন করতে হবে সেটা 3টে পয়েন্ট আছে।
Yes, very good. Very good.
Sir, we have to express beta in 3 different combinations.
Yes. Very good. Now listen carefully. So write down let alpha is equals to -1 to 4. Okay. Beta is equals to, please write down quick. -1 to 0. Gamma is equals to 0 -1 1. And delta is equals to 3 -4 2. Is it clear? First line is clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now you write down let alpha is equals to C1 beta plus C2 gamma plus C3 delta. Correct? What is C1? C1, C2, C3 are constant. Okay. Now you write down what is your alpha. -1 to 4 is equals to C1 -1 to 0 plus C2 0 -1 1 C3 3 -4 2. Correct? This line is correct. This line is correct.
Yes, sir.
Yes, sir.
Okay. Now please check. Can you write -1 to 4 is equals to, if you add component wise, then you have -C1 plus 0 C2 plus 3 C3 2C1 minus C2 minus 4C3 0 C1 plus C2 plus 2C3. Can you write this? Can you
Yes,
write
sir.
this? Okay. So from here we can write minus C1 plus 0 C2 plus 3C3 is equals to how much?
-1, sir.
Some -1.
-1. Then we can write 2C1 minus C2 minus 4C3 is equals to how much?
Sir, 2.
2. 0 C1 plus C2 plus 2C3 is equals to how much?
4, sir.
4.
Yes. Now we can see what is our target. Our target to find the value of C1, C2 and C3. Now you have a system of linear equation. Now our target to solve this system in equation to find the value of C1 and C2. From your 11-12, already you know, or in BTech already you know, there are different methods you have to solve this system of equation, where you can see 3 unknown. One is Kama's rule, number 2 is Gauss elimination method, number 3 is matrix inverse method. Okay, there are different
Yes.
methods you have. There are different methods you have.
Yes, sir.
Okay. Different methods we have, correct? Now our target to solve it. Now one of the easiest method we have, that is called Kama's rule. Correct? Easiest method we have, Kama's rule. Okay.
Yes, sir.
Yes, sir.
Now anyone can tell
Yes,
me
sir.
what is the value of del?
-1,
The minus
Minus
1,
1, 0,
1,
0, 3,
2, minus
2,
4, minus
-1, -4,
minus 4,
0,
0,
1.
0, 1, 2.
Okay, now use your calculator, or you expand it and find the result. -1, -2 plus 4 minus 0 into 4 minus 0 plus 3 into 4 minus 0. My calculation is correct? Please check the value.
The minus 10.
How much is
sorry.
coming? Minus? What value is
10.
coming?
It's a plus 10. Plus 10.
Plus 10 is coming. So that means this is not equals to 0. If it is not equals to 0, it means there exists unique value. So already you know from the Kama's rule, if your del is not equal to 0, then there exists unique value of C1, C2, C3. Now, anyone can tell me what should be a C1?
Sir,
Yes.
4
3 into 2 minus 0.
minus 0 হবে স্যার
Huh?
প্লাস 3 into 4 minus 0
Sir, last 3 into 2 minus 0.
This
স্যার
one?
অ্যানসার 4 আসবে
Yes,
স্যার
sir.
ইয়েস স্যার
Yes, sir. Sir, answer is 4, sir.
স্যার অ্যানসার
Okay,
ইজ 4 স্যার
maybe. 2 minus 0, that is 6. 6,
Yes, sir.
6 minus 2, that is 4.
4 yes sir
Yes, you are correct. Thank you. Okay, now how to calculate del C1? Anyone? How to calculate del C1?
-1, 2, 4.
The
Yes,
minus.
this portion, that means this portion should be replaced by first column for C1, second
Yes, sir.
column for C2, and third column for C3. Correct?
Yes,
Now
sir.
you write down 1, 2, 4, 0, minus 1, 1, and 3, 4, minus 4, 2. Everyone, please try to tell me what the value. Then I'm writing del C2. What will be the del C2? -1, 2, 0, -1, 2, 4, and 3, -4, 2. You also please write down the value, calculate the value. Then I'm writing del C3. What is del C3? This value should be replaced by this portion. That is -1.
del c2 is equal to 16 sir
Okay.
del
Let's
C1.
16, sir.
-1, 1, and -1, 2, 4. Now, yes, what is the value is coming?
16
Del
sir.
C1,
16.
16.
16. Del C2. Everyone, please check carefully. Everyone, please check carefully. So in del C1, we are replacing this. In del C2, we are replacing this. And del C3, we are replacing that portion from del. Huh? So I think already you know that. Anyone can tell me what is a del C2 value?
8, sir. 8.
8. Okay. What is del C3? Anyone?
Del C2 equal -16, sir.
-16 is coming.
Yes, sir.
Everyone, please check the value. 16, 8, or -7, 16 or not.
no sir -8 sir
-8 is coming. Oh, something is wrong, it means. Again, I have doubt. No, everyone, please check del C3.
+8.
Huh?
So del C2 +8.
yes sir +8
Del C2 +8, already you have it. Now I'm talking about del C3.
Sir, +8, sir.
+8 del c3 also
Yes, sir. Plus.
Should I write del C3 is equals to +8? Is it okay? Everyone, please check, because this is the vital area. If your C1, C2, C3 value wrong, ultimately you'll get wrong answer.
C3 sir 4 আছে sir.
Now I have a lots of doubt, I think.
Yes,
It
sir.
is
It's
coming
coming
4.
4, sir. Yes, sir.
All of you agree with this? 4 is coming or not?
Yes, sir. 4, sir.
Okay, so now
Yes,
we can,
sir.
okay. Then you know C1 is equals to del C1 by del. It means what? 16 by 4
Yes, sir,
is equals to 4. C2 is
Sir,
equals
the
to
minus
del
4 হবে না?
C2 by del is equals to, just you have to check whether it is coming or not. Del C3 is equals to del C3 by del is equals to 4 by 4. That is 1 is coming. So now you know what is C1, C2, C3, correct? Shall I move to the next slide?
Yes, sir.
Yes, sir.
Now you can write therefore that is minus 1 to 4 is equals to, you can write what is a C1. C1 is equals to 4. What is a vector? Minus 1, 2, 0 plus 2. What is next vector? That is, you have 0, minus 1, 1. And what is your C3 is equals to 1 into what is the next vector? That is your 3, minus 4, 2. Are you getting my point?
Yes, sir.
Now you can see all C1, C2, C3 are finite real value. So that means what? This alpha can be expressed as a linear combination of these 3 vectors, correct? So therefore you can write hence alpha. What is alpha? Basically this is your alpha. Alpha is equals to 4 beta plus 2 gamma plus delta, correct? So hence alpha is the linear combination of beta, gamma and delta. Is it clear or not?
Yes, sir.
Is it clear? Oh,
Yes, sir.
now. So if it is not possible to find the value of C1, C2, C3, in that case you should say linear combination is not possible. Okay. Now, shall I move to the next slide? Hello.
Yes, sir.
Wait a
Yes,
minute,
sir.
sir.
Okay. Now, please write down.
Sir, previous, sir, please. Once. Yes, sir.
Please write down linearly independent and linearly dependent set of vectors. Please listen carefully. Very interesting point I'm going to discuss. Okay, so our first part is linearly independent part. Listen carefully. Linearly independent part. Okay, please write down. A set of vectors alpha 1, alpha 2, alpha n is said to be linearly linearly independent. Linearly independent. If C1 alpha 1 plus C2 alpha 2 plus Cn alpha n is equals to theta, where C1 is equals to C2 is equals to C3 is equals to Cn is equals to 0, and theta is the null vector. Now try to understand definition. First try to understand definition, then I'll give some numerical example. A set of vector alpha 1 alpha 2 dot alpha n is said to be linearly independent. Okay, if this set of vector can be expressed like this: C1 alpha 1 plus C2 alpha 2 plus dot dot Cn alpha n is equals to theta. What is theta? Theta is a null vector. Okay, as well as if all C1, C2, C3 are 0. Listen carefully. In previous example, what is the value is coming? C1, C2, maybe 0, maybe non-zero is coming. But in this case, in case of linearly independent, all C1, C2, C3 must be equal to 0. Must be equal to 0. If it is possible, then only you can say thus this set of vector is linearly independent. Is it clear? I repeat. First of all, you have to check, you have to rewrite the all vectors as a linear combination of this form. Okay, after that, you solve it. If you can see all C1, C2, C3 are all 0, then only you can say that this set of vector is linearly independent. The concept is clear? The concept is clear?
Yes, sir. Yes, sir.
Okay, so first I repeat once again. First you have to rewrite the system of equation. So you have to create this linear combination. Okay, and right hand side part should be equal to 0. That is a null vector. Now you simplify this. You have to calculate the value of C1 and C2 and C3. If you can see all C1, C2, C3 are become 0, then you can say theta, the set of vector is linearly independent. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now you write down the next part, linearly dependent part. Please write down carefully. Very interesting. Okay. Write down a set of vector. A set of vectors alpha 1 alpha 2 dot dot alpha n, alpha 1 alpha 2 dot dot alpha n, okay, is said to be linearly dependent if C1 alpha 1 C2 alpha 2 plus dot dot Cn alpha n is equals to theta, where C1 C2 dot dot Cn are not all 0, and theta is a null vector. I repeat, a set of vector alpha 1 alpha 2 is said to be linearly independent if this. So that means this condition must be satisfied, this relation. And when you can simplify, your C1, C2, Cn are not all 0. It means what? One or maybe two element C1 out of C1, C2, Cn may be non-zero. So this is the basic difference in definition. if it is linearly independent, all constant must be equal to 0. All C1, C2 must be equal to 0. But if it is dependent, that any one or many two, at least one or maybe at least two, maybe non-zero. The difference is clear. The definition part is clear to all of you. Linearly independent, dependent.
Yes, sir.
স্যার লিনিয়ার স্যার ইন্ডিপেন্ডেন্ট যে আলফা এন থাকতো এখানে আলফা আছে ওখানে
হ্যাঁ
মানে স্যার ওখানে স্যার লিনিয়ারলি ইন্ডিপেন্ডেন্ট
typing mistake. It should be alpha n, na? Okay. Clear or not? The definition part is clear. The definition part is clear.
Yes,
Yes,
sir.
sir.
Okay. Now to understand with some numerical example. Now let's see with some numerical example. Now try to understand. So that the set of vectors 1 2 minus 1 0 1 2 is linearly please write down the question. Statement part clear?
Yes, sir.
Okay.
Yes, sir.
Now write down. Here, listen carefully. Here, okay. So let alpha 1 equals to 1 2 minus 1. Alpha 2 is equals to 0 1 2. Alpha 3 is equals to 1 4 minus 3. Clear?
Yes, sir.
Okay. Now, what is our objective? To express this into this form. Write down, let C1 alpha 1, C2 alpha 2, C3 alpha 3 is equals to theta, where theta is equals to 0 0 0. That is null vector. Now we can write C1 1 2 minus 1 plus C2 0 1 2 plus C3 1 4 3 is equals to 0 0 0. Is it clear? Is it clear to all of you?
Yes, sir.
Now we can write from here C1 plus 0 C2 plus C3 2C1 plus C2 plus 4C3 comma minus C1 plus 2C2 plus C3 is equals to 0 0 0. Can we write this?
Yes, sir.
So from here we may write C1 plus 0C2 plus C3 is equals to 0. 2C1 plus C2 plus 4C3 is equals to 0. And minus C1 plus 2C2 plus 3C3 is equals to 0. Is it clear or not?
Yes, sir.
Yes.
Okay. Now anyone can tell me what type of equation you have? Anyone?
O minus equation.
Yes.
Homogeneous.
Okay. Now if we can take on the right next page, it will be better for us. Now you have this. This is a system of linear homogeneous equation. Okay. Now you can see on the right side, I think you have a question in your mind. Why it is homogeneous, sir? Very simple. If all right hand side part are 0, then it is called homogeneous. Now anyone can tell me what is the value of del 1, 0, 1, 2, 1, 4, minus 1, 2, 3. Anyone can tell me what is the value of del? Please check.
Sir, 4.
Huh?
4.
4 is coming.
Sir, 0, sir. 0, 0.
Sir, 0, sir.
0.
Hmm?
0
Zero,
is
sir.
coming, sir.
0 is coming.
Yes, sir.
Yes, sir. 0.
Oh, sorry, sir.
0, sir.
Acha.
Zero,
0
sir.
is. Acha.
Sir, minus 6, sir.
Huh?
Minus 6, sir.
Now again, I have lots of confusion.
Sir, 0, sir.
No, sir. 0, sir.
Acha. 0 is coming, correct?
Yes, sir.
0 is coming.
Yes, sir.
Yes,
So
sir.
already you know if it is 0. So from the concept of Kamazul, if del becomes 0, what is your del C1? Obviously 0.
Sir,
What
0,
Yes,
sir.
sir. 0.
Del C2
Del
is
C2 is equal to
0.
0, sir.
All is
Del
0.
C3 is also equal to 0. So if del 0 and all del 1, del 2, del 3, del C1, del C2 all 0, then there exists what type of solution?
So many solutions.
Yes. Then there exists infinite solution.
Finite solution. Yes, sir.
Correct? Now we have to find that because ultimately our objective to find the value of C1, C2, C3. Our
পয়েন্ট
objective.
গুলো স্যার
হ্যাঁ?
কোঅর্ডিনেট গুলো স্যার আগের পেজে একবার দেখাবেন স্যার কোঅর্ডিনেট গুলো স্যার এটা C3 into 1 4 minus 3 হবে স্যার
হ্যাঁ?
স্যার ওই
Which
C1
line?
plus alpha
In which line? Which line?
স্যার সেকেন্ড লাইন স্যার C plus
This
C3
line.
equals to 1 4
This line.
No, sir. Second line, sir. Last C3 bracket 1, 4 minus 3.
1 4 minus 3 sir.
Listen.
Second line after late.
Okay.
Then
This one.
yes, sir.
Acha.
Sir C3
Okay. Let's see. C1 1 2 minus 1 0 1 2 1 4. Oh, sorry. It should be minus, na? Okay.
Sir.
Yes, sir.
Okay, sorry. Minus 3 C3. Now it should be minus. Okay. Now, ultimately it is coming. Now, everyone, please check this. Now, this is a homogeneous. This is a system of linear homogeneous equation. Correct. Now what is your del? Del is equals to 101 214 minus 1 2 minus 3. Now what is the
Yes,
value?
-6.
Minus
-6.
6 sir.
-6 sir.
Okay, let's see. Minus 3 minus 8 0 minus 6 minus plus 4 plus 1 4 plus 1. Correct? It is coming minus 6, not equal to 0. Okay. Now what is your del C1?
Del C1 is equal to 0, C2 is equal to 0, and C3 is equal
Yes,
to 0.
del C1 is equals to 0. Del C2 is equals to 0. Del C3 is equals to 0. Is it clear to all of you why I'm writing the direct value 0? Because del C3 is all about the replacement of first column of del by 0 0 0. Already you know from the concept of determinant, if any one row or any one column in any determinant is 0, the corresponding value of determinant is 0. Correct?
Yes, sir. Yes, sir.
Yes.
Already
Yes,
know
Yes sir.
that you have this. So therefore we can write C1 is equals to del C1 by del. So that means 0 by minus 6 is equals to 0. C2 is equals to del C2 by del is equals to 0 by minus 6 is equals to 0. C3 is equals to del C3 by del is equals to 0 by minus 6 is equals to 0. Okay. All C1, C2, C3 are 0. Correct? Clear or not?
Yes sir.
Yes sir.
All C1, C2, C3 are 0. So therefore you can write the set of vector, 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 the set of vector is linearly Is it clear or not? Is it clear or not?
So
Yes,
please
sir.
show the previous slides.
Definitely. Anyone, any doubt about the calculation? The part is clear. How to check the linearly independent part? How to check?
Yes, sir.
Okay. Okay. Achha. Shall I move to the next question?
Yes, sir.
Yes, sir.
Yes sir.
Now listen carefully. Another interesting question. Show that the set of vectors, so set of vectors 2 1 1 1 2 2 and 1 1 1 is linearly dependent of R3. Suppose you have this question. Now anyone can tell me what is the difference statement wise. I'm not talking about the logic or concept. What is the difference between last question and this question? Anyone can tell me statement wise, only statement. You go through statement, try to identify the difference. Anyone?
স্যার আগেরটা ইন্ডিপেন্ডেন্ট ছিল আর এটা শুধু ডিপেন্ডেন্ট আছে।
Yes, very good. So last one, it was independent question and here it is dependent question. Correct. Anything else?
Is it dependent of?
Sir, R3, sir.
Yeah.
Dependent on R3.
Yes. In last
What is
question.
R3 স্যার?
Yes, I'll explain. I'll explain. So here it is define only this vector. Okay. But now try to understand. Here I have mentioned of R cube means what? R stands for real. R cube means 3-dimensional space. So that means this vector is coming from 3-dimensional space and all data are real. Are you getting my point? Is it clear? Just you can see from the last question, here all data are real, isn't it? So here we can write of R cube. So that's why I have mentioned here of R cube. Hello?
Yes, sir.
Okay, so this is a basic difference. Sometimes you can see we of R cube, sometimes you may not this information. But when you can see the all data are coming from the real part, that means this set of vectors are all belongs to R cube. Okay, but concept all are remain same. Now let's see. Now try to understand this solution. How to check linearly dependent part? Let's see. Here 2 1 1 1 2 2 1 1 1, correct? So let, or you can write directly, you can write let C1 alpha 1, I'm changing little bit, huh? C2 alpha 2, C3 alpha 3 is equals to theta. On the right side you write down where alpha 1 is equals to 2 1 1, alpha 2 is equals to 1 2 2, alpha 3 is equals to 1 1 1, theta is equals to 0 0 0. Is it clear to all of you? Here I have changed the representation only, nothing else. So from here you may write C1 2 1 1 plus C2 1 2 2 plus C3 1 1 1 is equals to 0 0 0. So from here we may write 2C1 plus C2 plus C3, C1 plus 2C2 plus C3, comma, C1 plus 2C2 plus C3 is equals to 0 0 0. Can you write this? Can you write this?
Yes, sir.
So from here we may write 2C1 plus C2 plus C3 is equals to 0. C1 plus 2C2 plus C3 is equals to 0. C1 plus 2C2 plus C3 is equals to 0. Correct? Is it clear or not?
Yes, sir.
Just, but you can see from here basically two both equation are same, isn't it?
Yes, sir.
Okay,
Yes,
so
sir.
in that case you may write 2C1 plus C2 plus, if suppose there may be a chance to get different row also, then what you do, I should solve it in general. It will be better for you. It will be better for your better understanding. Okay, now come to the next slide. It will be better for you. So then what if by Kama's rule, then what you do, you have to find the del, isn't it? 2 1 1
Yes, sir.
1 2 1 1
স্যার
2
দুটো
1.
স্যার দুটোটাও সমান হয়ে গেলে 0 হয়ে যায় তো স্যার?
Obviously we should
Yes,
write
sir.
0. Okay, similarly, so already you know it is equal to 0. What is your del C1 is also 0, del
Yes, sir.
C2 is also 0, del C3 is also 0. Okay,
Infinite solution.
yes, there exists
Infinite solution.
infinite solution, but you have to show this. Okay, now so these two equations are same, isn't it? So you may write 2C1 plus C2 plus C3 is equals to 0, C1 plus 2C2 plus C3 is equals to 0. Can you write this? Can you write this?
Yes, sir.
Now use, I think you know cross multiplication technique from your class 7 onwards. You know that?
Yes, sir.
C1 by C2 by C3 by, you write down. C1, this into this by this, that is 1 minus 2, minus here, 2 minus 1, C3, 4 minus 1. So ultimately you have C1 by minus 1, C2 by minus 1, C3 by 3. Is it clear or not?
Sir.
Is equals to K, say, equals to K. That means you are considering some K. Okay. So therefore, what is C1? C1 is equals to minus K. What is C2 is equals to minus K. What is C3? C3 is equals to 3K. Can you write this?
Yes, sir.
Now you check whether you are considering these two equations, first and second. Now my question to you all, please check if you substitute this C1, C2, C3 value in third equation, whether it is satisfies or not. Whether it is satisfying or
Yes, sir.
not.
Satisfied, sir.
Okay.
Satisfied, sir.
Okay. So next line. Okay. Okay. Next line you write, therefore, the last equation is also satisfied by this. Correct? So now you can write since K is arbitrary, because you are taking K, some constant. Okay, K is arbitrary, correct? Then you can write there exists C1, C2, C3, not all zero. Not all zero. There exists C1, C2, C3 are not all zero. Whether all are zero, yes or no? Non-zero, na?
Yes, sir.
Yes,
Non
sir.
zero.
Yes, sir.
Yes, sir.
Yes, sir, non-zero.
You can write down hence.
Non-homogeneous.
Hence, the set of vector, the set of vector is this one. The set of vector is linearly dependent. Anyone, any doubt about the calculation? Anyone, any doubt about the calculation? Is it clear to all of you?
Sir, আগেরটা স্যার linearly independent and this is linearly dependent.
Yes. So here it is dependent. So that means here C1, C2, C3 are all not all zero. But in linearly independent, all C1, C2, C3 must be equal to 0. Clear?
Sir, can you show me
Yes,
the first slide of this question?
Sir, what is the difference between last and this question?
So last question, it was linearly independent where C1, C2, C3 all are 0. But here the set of vectors is linearly independent where C1, C2, C3 are not all 0. Is it clear?
Yes, sir.
Okay. Is it okay to move to the next slide? Shall I move to the next slide?
Yes, sir.
Okay. Now you write down some homework. Please write down some homework. Just you have to check whether your concept is clear or not. So that the set of vector, the set of vector that is 1, 2, 2, 2, 1, 2, and 2, 2, 1 is linearly independent of R cube. So this is only single one I want to give you as a homework. I think it is clear to all of you how to check it.
Yes, sir.
Okay.
Yes, sir.
Yes, sir. But sir,
R cube means three. This R stands for real. The R cube means three-dimensional space where you can see the set of vector all are real.
okay, sir.
Okay.
R for real.
Here it is independent.
Real.
Huh?
Independent, sir, in question. In last question, dependent.
Yeah. Yes. Last question dependent, and now it is independent.
স্যার আগের স্লাইডটা দেখো। ওকে স্যার।
Just show the second. Yes, sir.
Okay. Now try to understand the next part. So I think linear combination part is clear. Linear combination, linearly independent, linearly dependent part.
Yes, sir.
Okay.
Yes, sir.
So this is very important question. From here you can expect some question. Okay. So already you know from 28th onwards you have a final semester exam. Okay. And coming
28.
28 onwards you have a semester exam.
Okay, sir.
Okay, now listen carefully. Another interesting question I should write. So please write down. Generator set, spanning set. Generator set or spanning set. Then you write down basis. And then you write down dimension. Okay. Now try to understand this very, very interesting part. Generator set, spanning set, and generator set or spanning set both are same. If you consult different types of writers' book, someone using spanning or someone using generator. Okay, and it is a basis and then dimension. Now try to understand the definition part. A generator set or spanning set. Okay, what does it mean? Already you know that. So if you are a representative of if a set of, listen carefully, very interesting point. If a set of elements, if a set of student can represent, the whole university, then they are called the spanning set or generator set. Are you getting my point? Yes or no? If it is possible to represent your university reputation by a set of students, then you can say that set of student is a generator set or spanning set. Are you getting my point? Yes or no?
Yes, sir.
It means what? That means if you can represent, if it is possible to represent all by a set of group of members or by a set of elements, then this set is called the generator or spanning set. Okay, now try to understand with some mathematically, with some definition. Now listen carefully. A set of vectors, a set of vectors G, a set of vectors Z, or you can write a set of vectors G. That means this set is G. In a vector space V is called a generator set or spanning set, generator set or spanning set of V if
জি এর আগে স্যার ওটা কি স্যার?
that is if every vector of V, if every vector of V can be expressed as a linear combination of the vectors of G. I repeat once again. Listen carefully. Very interesting. But if it is clear to you, then it's become very easy. If it is not, then it's very tough for you. But if you ask me the same question, sir, what type of topic you have right now? Basically, it's a very easy, very simple topic you have right now. Now listen carefully. This is vector space V. That is a big part. So this is your G, where you have some set of vector. This is your, if I can compare this vector space, basically it is a Jisoo, and this G basically CSC department. Okay, so if it is possible to represent all quality of Jisoo by this CSC department, then we can say CSC department is the generator set or spanning set of Jisoo. Are you getting my point? Yes or no?
Repeat, sir.
I repeat once again. So this big part is a vector space set that is we are considering as a Jisoo. That means Jisoo is a big part. CSC, this is one part of vector, that is a G. So here we can consider G as a computer science department. If it is possible to express all the information of Jisoo with the help of CSC department, then we can say that CSC department is the generator or spanning set of Jisoo or vector space V. Clear?
Yes sir, yes.
Yes, sir.
Yes, sir, clear.
Okay. So now, that means whatever the suppose in except CSC there may be some B.Ed section, maybe some management section and all. But if it is possible, whatever the performance they can perform, our CSC department can do this. If it is possible, then we can say our CSC department is a generator or spanning set of the vector space V or Jisoo. Is it clear or not? Now I think it is clear.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now listen, very interesting part. If I can show you another example mathematically, because right now we are dealing with mathematics, na? Now I think your concept is clear with the GSU and CSE. Now it is concept is clear. Now try to understand. Suppose you want to understand, sir, how to express linear combination of all and all. You want to know this. Now let's see. Listen carefully. If I can write one numerical example, suppose if I can go back, if I can take this example, it will be better for us. Now listen carefully. Very important point I'm going to discuss. Listen. Now, another example. So already you know CSC example. Now, listen carefully. Already you have proved it from the linear combination. Listen, what I'm going to discuss. This is your GSU, or you can say vector space. Okay. So here you have a CSC department. CSC department with some vector that is -1, 2, 0, 0, -1, 1. Another is 3, -4, 0, 2. Okay. Is it clear or not? This is your CSC department.
Yes, sir.
That is your G.
Yes, sir.
Listen carefully. So this -1, 2, 4. One student is coming from other part. This student is from GSU also. This student is also from GSU. Okay. Now you can see this student, whatever the performance he or she has, so you can perform. It means what? You can replace him. Means what? That means this vector can be expressed as a linear combination of these three vectors. This vector can be expressed as a linear combination of these three vectors. Then you can say, if it is possible, then you can say this is a generator. Is it clear or not?
Yes, sir. Clear.
Sir, repeat
Okay.
once again.
Just from here it is clear that if you simplify, if you multiply 4 into this vector, 2 into this vector, 1 into this vector, just you do that. If you multiply, if you add all together, then you will get this result. Just you check. Just if I can check it, let's see. That is -4, 8, 0, plus 0, -2, 2, 3, -4, 2. Please check. If you add, that is -4 plus 0, -3. 8 minus 2 minus 4. Please check. 0 plus 2 plus 2. Ultimately, you check, if you add all together, you have -1. So plus 2, and here it is 4. Is coming or not?
Yes, sir.
Yes, sir.
Yes,
From
sir.
vector, so this new vector can be expressed as a linear combination of these three vectors. No
Yes, sir.
need to write this. So this vector can be write with the help of these three. So that's why this set of vector is called generator or spanning set.
Yes.
Okay. Now, so I'll give some numerical example. No tension. I'll explain now. So I think generator part is over. Then you write down basis. Please listen carefully. Very important point I'm discussing right now. But very interesting, very interesting. But if your knowledge is clear, then you can solve all types of questions from here. Very interesting. So please write down a basis of a vector space. So that means basis means a basis of a vector space. Okay.
Sir, can you show the last slide?
Okay.
Yes, sir.
Okay. Now, a basis of a vector space is a subset of V, which is number one, linearly independent. Which is linearly independent. Number two, a basis of a vector space is a subset of V, which is linearly independent as well as a spanning set. Now listen carefully, very interesting point. So this is your vector space. So this is your one subset, if we can say S. If this S is linearly independent, and spanning set, then this set is called basis of vector space V. Clear or not? Is it clear or not?
Sir, if subset S is a linearly independent and spanning set, then S is called basis of vector space V.
Basis of vector space V. Okay. Is it clear?
Yes, sir.
Yes.
So
Yes,
first
sir.
to identify from vector space, you have to identify some subset. Just you have to prove that subset is linearly independent as well as spanning set. Then only you can say it is a basis of the vector space. Is it clear? I'll show you with some numerical example, but try to understand the concept. What is the meaning of it? Basis of a vector space. What does it mean? A basis of a vector space, basically it is a subset of vector space V, and which is also linearly independent, number one. Number two is a spanning set. Then you can say the corresponding set is a basis of vector space. Clear?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Anyone can tell me, can you recall class 11-12 concept? Cardinality number of a set. Anyone? Cardinality number of a set. What does it mean? Cardinality number of a set. Do you know that?
No, sir.
Okay. I'll explain. Now you write down most important part, that is a dimension. Please write down dimension of a vector space. Dimension of a vector space, or you can write basis of a vector space. Basis of vector space, both are same. Okay. Dimension of a vector space. Listen carefully. Dimension of a vector space. Listen carefully. The dimension of a vector space the dimension of a vector space is defined the cardinality of its basis. I think some part is unknown to you. So now you know what does it mean by basis. So now your part is cardinality is unknown. Okay. Now let's see. Now one set is here S. Now anyone can tell me this S set, how many characters you have, letters you have?
4.
4, correct? So n of S is equals to 4. That means the cardinality of S is 4. That means in a set, how many number of elements you have, that number is called the cardinality of that set. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now anyone can tell me for second question, what is the cardinality of the second set?
Sir,
6.
Sir,
Very,
6.
very good. Another example. What is the cardinality of set
5,
S?
sir.
5.
5.
Is it clear? So now, first just you can see the dimension of a vector space, its mean. So first you have to identify what its basis. In basis means a set of vectors. First you have to identify its basis. Okay, then you have to check how many vectors you have in that basis. So this number is the dimension of the vector space. Is it clear or not?
Yes, sir.
Is it clear? So first you have to,
Yes, sir.
first you have to find the basis of the vector space. Then you have to identify how many vectors you have in that basis. So this number is the dimension of the vector space. Okay, now listen carefully. Example. Now try to understand the example, then you can get some confidence. Suppose S 1 0 0 0 1 0 and 0 0 1 is a standard basis of R cube. Standard basis of R cube. Listen carefully. So here R cube as a vector space. Is it correct or wrong? And this S is a basis. Now we want to know dimension of vector space R cube. Anyone can tell me what will be the result?
Sir, 3.
Sir, 3.
Yes, why it is 3? Why it is 3?
So number of
Why it is 3?
Because there is 3 numbers.
Yes, in basis, there are 3 vector you have. That's why the dimension of the vector space is 3. Is it clear or not?
Yes, sir.
Okay. Another example. Then I will show you how to find it. I will show you, but first you write down some examples. It will be better for your understanding. Suppose another example. S is equals to 1 0 1 0 1 1 1 1 0. Suppose.
Last slide, please, sir. Yes, sir.
Is a basis of R cube. So already know that. So that means what? This is your vector space. So this is your basis. Okay. Now I want to know dimension of what is that?
3, sir.
3.
3.
Yeah.
Three.
Why? Because you have in basis there are 3 vector you have. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Now you know. So what is the definition of basis? A set of vector, if it is linearly independent as well as a spanning set, then it is called a basis. Correct?
Yes, sir.
Yes, sir.
It is a basis. Now I want to give you another example. Prove that, listen, prove that 2, 1, 1, 1, 2, 1, 1, 2, 1, 1, 2 is a basis of R cube, and find dimension of R cube. Anyone can tell me what is the dimension of R cube? Anyone?
3.
Sir,
Yes.
3.
Very
Three,
good.
sir.
Very good. Very good. Because if you can prove it that this set is a base, then automatically we can say there are 3 vectors you have. So that's why the dimension of R cube is 3. So now I'm going to discuss how to prove a vector is a basis. Now try to understand this. So how many parts you have? Anyone can tell me how many parts you have to prove as a basis a set of vectors? How many parts you have?
Sir, 3.
3 points.
The 2, sir. Linearly independent or spanning set.
Yes, on first one is linearly independent and second one is spanning set. Okay. Now you write down part by part. Now write down the heading linearly independent part. Linearly independent part. Okay. Now let us consider the relation. Let us consider the relation. Anyone can tell me the relation? Anyone? I'm talking about which relation?
C1 alpha 1.
C1 alpha 1 plus C2 alpha 2
C2 alpha 2 plus C3 alpha 3 equals
3
theta.
equals to 3.
Yes.
Tn alpha equals to theta, sir.
Very good, very good, very good. C1 alpha 1 plus C2 alpha 2 plus C3 alpha 3 is equals to theta. Now we can write down where theta is equals to 0, 0, 0, alpha 1 is equals to 2, 1, 1, alpha 2 is equals to 1, 2, 1, and alpha 3 is equals to 1, 1, 2. Okay, now you substitute everything over here. That is C1 2, 1, 1 plus C2 1, 2, 1 plus C3 1, 1, 2 is equals to 0, 0, 0. So from here we may write 2C1 plus C2 plus C3, comma, C1 plus 2C2 plus C3, comma, C1 plus C2 plus 2C3 is equals to 0, 0, 0. So therefore we may write 2C1 plus C2 plus C3 is equals to 0. C1 plus 2C2 plus C3 is equals to 0. C1 plus C2 plus 2C3 is equals to 0. Am I correct? Am I correct?
Yes, sir.
Okay. Now, what is our target to find the value of C1, C2, C3?
Yes, sir.
Okay. So here, what type of equation you have?
Sir, homogeneous.
Homogeneous equation.
Homogeneous equation.
Mention it. This is a homogeneous system of three equation. Correct? Of C1, C2, C3. Okay. Now you know Kama's rule. Now anyone can tell me the constant part. Anyone can tell me the determinant part. What is a del?
2 1 1
Yes.
1 2 1
Okay.
1 1 2.
Okay. Anyone, can you tell me the del value? Everyone, please check. Please check the value. What value is coming?
Sir.
I don't know. 4. Okay. Not equal
Yes,
to
sir,
0.
4.
If it is not equals to 0, then what kind of solution we will get? If del become non-zero, then what kind of solution we will get? Unique solution we will get. Okay. What is your del C1? What is your del C1? This part will replace, correct?
Yes,
Yes,
sir.
sir.
0 0 1 1 2 1 1 1 2. So it is 0. What is del C2? So already you know
0.
that. That is this part should be replaced by 2 1 1 0 0 0 and 1 1 2. Ultimately it is coming 0. Del C3, that is 2 1 1 1 2 1 0 0 0. It is also coming 0. Okay, so that means from del you are replacing that portion by the right hand side part. Okay, so what is coming? That is your C1 is equals to del C1 by del, that is 0 by 4 is equals to 0. C2 is equals to del C2 by del, that is 0 by 0, and C3 is equals to del C3 by del, that means 0 by 4 is equals to 0. Is it clear or not? Okay, if C1, C2, C3 are 0, that means what? Therefore, the set of vectors means what? Means what? 2 1 1 1 2 1 and 1 1
Independent.
2 is linearly independent. Is it clear?
Yes.
Yes, sir.
Okay. What is our next checking?
As well as spanning sets. Sir.
Spanning set or generator set.
Yes. Now we want to check whether it is a panning set, yes or no. It is a panning set, yes or no. Okay. It is a spanning set, yes or no. Okay. So in a single step, you can write. In a single line, we can write. But I want to describe not in a single line. I want to describe it in general, how to check it. Okay, now come to the next part, that is your generator set. Set or spanning set. Spanning set. Okay. If we can prove it that your set is linearly independent as well as generator set, then we can say that set is a basis of R cube. Okay. Now listen carefully. If possible, listen carefully. If possible, okay, first you have to write down. Let beta belongs to R cube. Be any arbitrary vector. Listen carefully. Listen carefully. I am taking any arbitrary vector from R cube. Anyone. Now let's see, is it possible to express beta with the help of alpha 1, alpha 2, alpha 3? Is it possible to express? Then let's see. So you write down is possible, if possible. Right now we don't know. If possible, beta is equals to C1 alpha 1, C2 alpha 2, C3 alpha 3. Are you getting my point?
Yes, sir.
If it is possible to express,
Yes, sir.
that means
Yes, sir.
there may be a confusion between C1, C2, C3. So it will be better if we can write like this. A alpha 1 plus B alpha 2 plus C alpha 3. Because in C1, C2, C3 and this A, B, C are totally different. Okay. Now, if possible, if beta can be expressed into this form, if it is possible, where A, B, C are all finite value, finite real value, if it is possible to express, then we can say alpha is a linear combination of alpha 1, alpha 2, alpha 3. Okay, what is beta? Basically, beta is any arbitrary vector. So that means any vector of R cube can be expressed as a linear combination of alpha 1, alpha 2, alpha 3, provided if you can prove it, or you can express it as a linear combination of this. Now listen, let's see. So here we can write what is beta. Basically, you can write beta 1. Beta 1 is a vector, so that means there are 3 components, isn't it? Beta 1, beta 3. Listen carefully. A 2, 1, 1 plus B 1, 2, 1 plus C 1, 1, 2. Can you write? Can you write?
Yes, sir.
Okay. Now, if I can write from here, beta 1, beta 2, beta 3. Basically, what you have, 2A plus B plus C, A plus 2B plus C, A plus B plus 2C. So from here, we may write 2A plus 2B is equals to beta 1. A plus 2B plus C is equals to beta 2. A plus B plus 2C is equals to beta 3. Can we write this?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So now,
Yes,
so it's
sir.
a, what type of equation you have?
Non-homogeneous.
Yes, this is a non-homogeneous system of equation for A, B, and C. Why it is called non-homogeneous? Because right side part you have some value, are not all 0. Okay.
Yes, sir.
Are not all 0. Now it's a, by Kema's rule we can find it. By Kema's rule we can find it. Okay. So now you tell me what is the determinant of it. If we can take it outside. Now listen carefully. Okay. So what is your del? Del is equals to 2, 1, 1, 1, 2, 1, 1, 1, 2. What is value? 4 minus 1 minus 2 minus 1 plus 1, 1 minus 2. Correct? What is that? 4 not equals to 0. Correct? Hence by Cramer's rule, there exist unique solution for A, B, C. This line is clear or not? This line is clear or
Yes, sir.
not? Okay. Okay. Now you please listen carefully.
Yes, sir.
So if there exists unique solution, whatever the value beta 1, beta 2, beta 3 you have, whatever, you will get some unique value for A, B, C, correct?
Yes, sir.
Yes, sir.
Yes, sir.
It means what? The beta can be expressed as a linear combination of these three vectors.
Yes, sir.
Yes, sir.
Yes, sir.
So then you can write down, therefore, R cube is equals to linear combination of 2, 1, 1, 1, 2, 1, 1, 1, 2. Is it clear or not? I repeat once again. What is beta? Beta is an arbitrary vector, arbitrary in any one, general. So if you have by Cramer's rule, there exists unique value of ABC. If ABC unique, so that means beta can be expressed with the help of these three vectors.
Yes.
That's why writing R cube, all R cube can be expressed as a linear combination of these three vectors. So
Yes,
now, therefore,
Yes, sir.
this 2, 1, 1, 2, 1, and 1, 1, 2 is a generator set or spanning set of R cube. So now it is proved that your set is linearly independent and spanning set. Hence, 2, 1, 2, 2, 1, 1, sorry, 1, 2, 1 and 1, 1, 2 is a basis of R cube. Is it clear or not? And dimension of R cube is equal to, there are three vectors you have. Is it clear?
Yes, sir.
All parts clear to you?
Yes, sir.
Okay. So this type of question you can expect from here. Very simple example. But if you consult different writers' book, they are ignoring this calculation. They are within one line they can write this. You can write also, but this is the first time I'm doing. That's why I should explain the process, how to prove it. Okay. So first you have to prove that your set of vectors is linearly independent. Then you have to prove it's a generator or spanning set. Then you have to conclude the result.
মানে স্যার বেসিস স্যার আনতে গেলে স্যার মানে দুটো কন্ডিশন আমাকে রাখতে হবে।
Yes. Okay, now our time is running. Now please, everyone, please check your attendance. Everyone, please check your attendance. Time is running. Can you see my screen?
Yes, sir.
Yes,
Hello. Everyone, please check your attendance. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. Thank you. You may leave
Thank
the
you, sir.
class. Thank you. Okay. Bye bye.
Thank you, sir.
Bye-bye, sir.
Okay. Bye bye.